All right. Hello, Penn, Ohio family. It's Mike O'Dell. I have with me today Charles Dillard from Amphenol Broadband Solutions. Charles is the training manager at ABS. And while Amphenol has a wide range of products for a very diverse set of technologies across multiple industries, I've asked Charles to join us today to talk specifically about their new hardline connectors. How are you, Charles?
I am great, Mike. Thanks for the invite. So appreciate that.
Well, thanks for joining us. This is one that I think a lot of people that have been in the industry for a while just sort of assume, a hardline connector is a hardline connector. What's the
Yeah.
big deal? And so you and I have been talking about this for a while. Amphenol's been developing a new line of hardline connectors now for a couple of years. And I thought it was important to really talk about the product itself, um, and then also hardline connectors in general, because I do think they're underappreciated for, the importance that they have in the
Yes.
network. They're a critical component that is often overlooked. We spend a lot of time paying attention to the amplifiers and to the cable
Mhm.
and to, the active devices and other things. And we just sort of assume that a hardline connector is a hardline connector and it's just gonna work.
That is so true.
And that may not necessarily be the case.
Yes.
As
But yeah, before we even get into the presentation, uh, a little off topic, but not. I remember when I first started working on a two-way cable plant, and we were introducing internet service for the first time, so two-way system, and I
Mhm.
was tracking a return outage. So the forward television was working, but all the modems were offline. So I do my process of elimination, doing divide and conquer, and going through the amplifiers and stuff. Finally found a leg that the problem, the noise was on. And so then I had to go from, tap to tap to isolate it. And it was a drop. And I followed that drop. And it was a connector that had just been pushed on, not crimped. And it was gold looking. It wasn't one that we had at our company. And but that noise shut down the return in that node. And it wasn't until years later where it really hit me. And when I got into training, which was, if you think about from the node all the way to this customer's house, the amount of equipment between it, and the prices of those optical nodes and amplifiers and passes, and it was like a 40-cent connector that
Yeah,
shut down the return in that entire network. So when someone thinks that it's just a connector, it's not. That connector
it's
is just as
not.
important as the CMTS, the node, et cetera, to your earlier point. And same thing with the hardline connector. So I think this is a timely conversation.
Well, and to follow up on that point, I've had the conversation with techs before. Even if you start in the premise, if you add up all of the components that make up a premise network, right? You have to start at the tap with a connector and then a segment of cable and then another connector and a ground block and another connector, another segment of cable. It is a large number of components, and most of them are connectors,
Yes.
right? And to your point, it's a very often overlooked component because they're so ubiquitous. They're everywhere. And the hard line is exactly the same. For every one segment of cable, you have two connectors. You
Yes.
have to, right? And typically at an amplifier, you'll have one amplifier, but you could have four, five, six different connectors attached to it, depending on the style of the amplifier, the node. So they are terrifically important. And as we're finding, particularly in the context of the expansion of like DOCSIS 3.1 and DOCSIS 4.0, where we have higher order modulation, wider bandwidths, particularly in the downstream, talking about going out to 1.7, 1.8 gigahertz, in the future, maybe 3 gigahertz, maybe farther. I have heard from
Yes.
Cable Labs, we're talking about potentially 6 gigahertz someday over coax. Man, That is why we need to have this conversation about hardline connectors because they matter. I'll go ahead and jump into the presentation, and there's a lot here, and I look forward to, talking through specifically your connector, why it's different, what's new about it, how does it differ from, previous generations of hardline connectors. And so let's start there. Let's talk about
Okay.
your new hardline connector.
All right. Thanks. So as we'll go to the next slide and just talk about a little bit about connectors in general first, and then we'll dive into our cool one. And even like the title says, understanding the design is that once you know whether we're talking about a connector or any product or piece of equipment or tool, once you understand how they're designed and why they are designed a certain way, uh, you'll be more keen to want to either install it properly, knowing that if it's not installed properly, what would be the signature of that, especially when it's time for like troubleshooting. Because and what we'll talk about a little bit later is that how craftsmanship will play an important role when it comes to hardline connectors. Uh, just like with any piece of equipment that we're installing on the network. So again, it's important to understand how it's installed, because in doing so, like I mentioned, you'll be able to install it right and seal it correctly. And then also when it's again time to troubleshoot it later, you'll know what to look for based on the impairments that you're seeing out in the field.
So
Go
you
ahead.
mentioned the weatherproofing. Okay. Riddle me this, Batman. Do you actually need shrink boot on a hardline connector in an aerial outdoor application?
So I will start off like I start off with any of my presentation or training, especially as we travel around the different MSOs and stuff. I lead with follow your company's policies and procedure when it comes to installation and safety work and engineering. When we design connectors as a vendor or a manufacturer, the testing that goes into it, we test our connectors, various tests, submerging them, in water and et cetera. It's designed to where you don't need heat shrink. It is an added value to have that installed over the connector, and I know a lot of MSOs, they choose to do that. But it's designed and not only from just a design perspective, but um, you know, anything could be designed perfectly, but if it's not installed the way that it was meant to be, you can have the best product in the world, and if you don't follow, the guidelines or step by step, you can have issues. But to answer your question, you don't have to have additional shrinkage for protection against the environmental elements, rain, snow, moisture, etc.
Okay, so follow your company's construction or installation guidelines.
Number
However,
one.
from the manufacturer, they are designed and built not to require
Yes.
additional weatherproofing. Okay, thank you.
All right. So what we're looking at now, and continue understanding design, when you think about the connector, it's designed, number one, not that there's an order to it, but it's designed to maintain a cable impedance. So like you mentioned earlier about, there's many different parts of a network. When you look at, the cable, the connectors, and the taps and passive devices and amplifiers, in order for it to work properly, uh, they have to maintain a certain impedance. So in our industry, that's 75 ohms. So number one, even how they're designed, I think we'll talk a little bit more about it in a couple of slides. But number one, maintaining an impedance matched throughout the entire network is very important. If not, then you start running into issues, with reflections,
Reflections and yeah, impedance mismatches.
yes, VSWR, so your voltage standing waves ratios start to alter. And, because it's harder to fix those issues after you install the hardline connector, because you have to be able to track to figure out where the problem's coming from. So again, installing it correctly and understanding the design of it will help when it comes to maintaining the cable impedance. Number two, they're designed in a way to help with weatherproofing. So you mentioned earlier about, do you have to have heat shrink, or and it's not required. Also, the connectors are designed, or hardline connectors are designed, with O-rings, and that will help to prevent moisture from getting in the connector, which will cause impairment on the cable. So when you think about, like, even with the O-ring, or even like if you've ever worked on a passive device like a tap or splitter, or even an active device, you'll see like there's a rubber uh, grommet or a ring around
Hmm.
those pieces of equipment to help
Yep.
moisture get out. And the reason why I bring it up is that I remember many, many moons ago being out in the field, and I went to help a technician with, I don't know if it was an outage or just a poor signal quality. Um, and they were having issues, with starting when they closed the active device, and they made a comment that, man, these little rubber things always get in the way, and they removed it. And I was like, what are you doing? And it was like, well, it's easier to close with this rubber gasket off of it. And I was like, do you know why it's there? And they didn't know it was there for, to help with moisture and stuff. And so then I asked them, do you know why the metal mesh is there
Gasket.
for?
Yeah.
And so
Purified gasket.
again, yes. So just like with those active devices and passive devices, hardline connectors, have mechanism built into it like O-rings to help with weatherproofing as well. Um, and then lastly, provide high frequency performance and RF power. Again, you mentioned, earlier in the broadcast here, design that, even though you may be operating at a certain, bandwidth today, certain megahertz, but you're not going to always be there. So eventually you want to go out to, 1.8 and, 3 gigs eventually. So what you don't want to do is have to go back and change out every connector that isn't, rated for those higher frequencies. So as companies like ours and others, when we design pieces of equipment or products, we want to look and be future proof, knowing where the industry will be in the next 5, 10 years.
Well, as fast as our industry is moving, I don't know if it's possible to be future proof. But in as much as possible, I know everybody's trying to be future resistant.
Yes.
And I think it probably bears stating again that in a lot of instances, these cable networks have been deployed for 20, 30, 40 years in some cases.
Okay.
And when they were installed, there's probably hardline connectors out there, like trunk connectors and things that haven't been changed in 20 years, maybe longer, which is great.
Yes.
However, it bears mentioning that the networks that we're deploying today in DOCSIS 3.1, DOCSIS 4, whether it's frequency division diplexed, extended spectrum DOCSIS, whatever you want to call it, or FDX, there's more total power on the network in higher frequencies than we've ever had before. And I do think that technicians are going to find when we start to operationalize and deploy these new designs that the connectors are actually tuned. And I think we're going to talk about this later. Is there's a frequency response plot for every component in the network, whether it's the
Yes.
tap or the node or the cable or whatever. The connectors do too, but we've never talked about it, Charles, because I think we haven't had to. The networks that we've operated out to 750 megahertz or 1 gigahertz for the last, 20, 30 years, we we've never had signals above that to see the tuning of the connector or, and even the cable in some cases. The MC squared cable is one that I use a lot as an example. That cable had a frequency specific notch in it, right? When it was first manufactured back in the early to mid 1980s, the frequency notch that's created as a result of the disk spacing in the cable was out around 315 megahertz or so, somewhere, which we think is really low. But back then, that was actually at the upper end of the spectrum, in some cases beyond the downstream spectrum. They were only using, 270 to 300 megahertz of active analog video channels with no return, right? So they didn't see the notch until they tried to upgrade their system to like 330 or 450. Then all of a sudden, this notch is in the active downstream, and they're like, hey, what is that thing? And they realized it was a notch in the cable, right? Because of the spacing of the disks. So they're like, oh, okay, well, if we move the spacing of the disks, the notch moves farther out of the passband. So they moved it out to like 450, which was good for a while, right? And then they upgraded to 450, 550 megahertz. Now all of a sudden the notch shows up again.
Yes.
It's like, wait, what is that thing doing there? Let's move it again. So they moved it out to like 600 megahertz. And I say that to say this. After 1989, they moved it above 1 gigahertz in any of the cables made after 1989. But guess what? As we go to 1.7 and 1.8 and beyond, we're going to find it. So there are gremlins like that out there, I suspect, in connectors and other components that we've never seen, but they've been there all along because we haven't either thrown enough power at it or enough bandwidth at it to expose the problem. And
That is so true.
yeah, we're going to
And
find them.
yes, and you're the stuff that you're talking about now is even just from a perspective of just changing, moving out the bandwidth. If you look at what we're doing with the return with mid split and high split, things that used to show up on the forward. Now we have to keep in mind now as we move the upstream bandwidth, when we talk about leakage, we talk about FM interference and all of that stuff. Now it's showing up in the upstream. So it's always been there and we always had to think about it. But now we have to put a different hat on, and figure out, okay, how does it show up now on the upstream when we used to just have to deal with it on downstream stuff. And also, yes,
Yeah.
good stuff.
No, that is exactly right. When you think about like FM frequencies and even VHF frequencies, those were previously downstream problems. And if there was ingress anywhere, it only went, typically it was in the drop system, right? And it, affected maybe a customer. But then we moved the diplex. Now it's an upstream frequency and it affects everybody.
Yes.
And
then later on, and then, I didn't mean to cut you off, but I think we're gonna just have a brief discussion on like FDX, where now you got upstream and downstream, intermingle. So now it's a different issue. So
yeah, for sure.
So what we're looking at now is thinking about a connector design, from the different portions of it. So the connector body portion, and I just want to read the second part of this. The purpose of it is to provide a mechanical interface to equipment or another cable and housing, all the other parts. Getting to with our hardline connectors. So connectors are typically made out of brass or aluminum, and but they could be plated, with nickel or tin plating, or a combination of the two. And there's reason, why someone would choose to manufacture, aluminum or connected with either aluminum or brass. And they each have its advantage. It's not to say that, if a connector is made out of aluminum, it's a bad connector. Kind of like you mentioned earlier, we have connectors that's been out there for 25 years, 30 years maybe, and they're still functioning. Maybe
Right.
when we go to 1.8, it may eventually start to show its ugly head or whatever, just because of wear and tear and everything else. But it doesn't mean that it's a bad connector. So I kind of want to say that first before I think as we get into like our connector, one thing I don't want to do is bash anyone else's connector because it may be
Right.
a little different. But in this image here that we're looking at, you see the different components of the connector. So on the far right, we have the connector body. Uh, the big thing about with the connector body to keep in mind is that it needs to be, strong enough to be able to, support pull tension, especially with aero insulation. Especially when we start talking about later about craftsmanship, torque from, tightening or over tightening. So because there are some people that feel the need to give it an extra or two. And I'm a small frame individual, so no one ever had issues coming behind me and removing my connectors, but I've had to struggle with you know people over torquing and Lord forbid if it's been cross threaded. So as you are aware, sometimes the only way to get those things off is to cut them off.
Yeah. Well, I'm the opposite side of that spectrum, Charles. I'll be honest. People say, "Well, who's the 900-pound gorilla that installed
Yes.
this thing?" Yeah, that was
Okay.
probably me.
Gotcha. Yeah.
Uh,
So pull tension and over torquing is two things that connector body is designed to either offset or to be able to withstand. The other thing is they're designed, especially in aero insulation, vibration from the wind and passing traffic. You want to be mindful of that. A little off topic, if you ever had to install like housing to housing equipment, especially near highways and aerial installation. A lot of time over time it can work its way loose. And with housing to housing, manufacturers typically have a locking or a non-locking housing to housing, and where one would maybe tended more for like indoor use. But again, whether we're talking about housing to housings or in this case hardline connectors, the connector body needs to keep in mind that they need to be designed to where they can withstand vibration that may occur from wind or large transport or trucks that pass by, especially around highways, etc.
I know you don't want to talk about it, but I do, and that is the materials and
Okay.
the different types of metal. So I appreciate your consideration for other designs and other
Yeah.
materials used by other manufacturers, but
I will
you
talk
know,
about it. I just didn't want to come across as bashing. So
yeah,
I'm definitely going to talk about, especially, I think it's like a couple of slides when we get to our new design. But yes, I didn't
okay,
mean to
good.
interrupt you.
Yeah. Okay. So I won't go too deep, but it is important to think about. I say this all the time. Function follows form. When you're talking about design, the way that a thing is designed will determine how it performs, right? And whether it can do what it is that you need it to do. And part of that is the materials that something is made of.
Yes.
Particularly when we're talking about passing electrical signals like we do, materials matter in what the thing is made of.
Yes.
And as important as the materials, we have to rationalize that there are different metallic conductor types. And whenever you have two different metals that come in contact with each other, right, it can present itself a problem. Dissimilar metals in the presence of corrosion have galvanic properties that cause major issues in cable networks. Anybody that's ever chased common path distortion
Yes.
is well aware of what happens with dissimilar metals. And so it's important to understand what your component is made of, how many different metals, and where those different materials come in contact with each other as you're transitioning from one component to another, right? Because it can actually determine whether it can result in a problem that effectively a technician's going to have to go fix. So I want to make sure that we're, having that conversation of like, hey, what is this thing made of? How many different metals are in it? Like, what are the metal to metal surface contacts where dissimilar metals could be brought together, and potentially what that can cause.
Oh, that is
So
tr so true. Even like to your point about those dissimilar metals with common path distortion, understanding, like you said, understanding that those similar metals can cause issue on the network. Like I mentioned about signature, typically like with CPD, you would see it, every 6 megahertz. And which, again, understanding how it shows up on your network will definitely help you with troubleshooting.
yep,
We will never get away from using dissimilar metal, for various
right,
reasons. Because, some portions of that hardline connector shouldn't be aluminum or brass. Because if it needs to be a great conductor, then silver may be used for that portion of it, or gold, because
gold, yeah,
it is a better conductor. And depending on what you need it for. If you need to, protect it from like corrosion and stuff, there's metal that are better suited for that. So when you started talking about the plating, with the nickel or tin, so you're exactly right. On the other side, there's problems we run into when we're using the same material, especially when we start talking about with galling and cold welding that I
yeah,
think we'll talk about a little bit later. And so that's issues there as well. So it's, like kind of pick your poison as to, which issue you want to deal with, the dissimilar metals or metals that are similar, but they can
right,
still cause a problem if your craftsmanship isn't the way it should be.
yeah. So I will say this. I've said this about a lot of different things, whether it's amplifiers, transmitters, receivers. Almost every component that's in our network has its own personality a little bit,
Yeah.
right? And if you understand the personality of that thing, then they're easy to work on because you know what to expect. You know how they're going to behave. And what I want to get to today, Charles, with this connector is I want to understand the personality of this connector, because as a technician
Yes.
that's going to be out there and installing these things, once you figure them out, it becomes second nature. It's easy, you know what to
Yes.
expect. And I think this is a quality product, but it has a different personality maybe than what we're used to.
Yes. So we'll the next couple of slides I'll hit briefly, just because this will these apply to all connectors, what we're going to talk about. Um, but when we get to ours, to your point, there's some things that are a little different that we definitely need to make people aware of, especially as they start to work its way into their companies and on their network, et cetera. So here we're looking at the O-ring. We talked a little about it earlier. Its main function is to prevent water, dirt, and other things that we don't want inside of the connector, or making its way through the cabling itself, from entering the assembly of that connector's body. But there are some things that, it's one thing that the O-ring to be missing, but it's another thing for an O-ring to be damaged as a result of like poor craftsmanship. So if you, I think we'll talk about tools a little bit later, but if you don't have the proper tools when you're coring the cable, et cetera, it can cause problems on that O-ring and cause damage, which can cause, problems later on. So again, O-ring is there as a a form of weatherproofing. Different connectors comes in different flavors, maybe different colors, but they serve the same purpose. The internal dielectric. So when we think about dielectric, the big thing is spacing between, in this case, the center pin and their outer body. So that way it maintains that impedance that we talked about earlier. Um, you know, you know, it's, I guess in your background, are they typically made out of the same material or
Um,
mostly?
Not necessarily. I think the important part is the insulation property, right? Because it is a dielectric and it's intended to, you know, protect the electrical properties of both the inner conductor and the outer conductor while maintaining separation. And to your point, maintaining the matched impedance. So it's really again, when we think about coaxial cable, we tend to think that there's actually just one conductor, and that's the center conductor. But the reality is there's two. The inner conductor and the outer conductor have to work together to maintain both the ground plane and the transmission properties of the cable.
Yes.
So the connector does as well, right? In order to allow the circuit to be completed, it requires good electrical conductivity on the
Yes.
outer conductor as well as the inner conductor and maintaining insulation in the impedance of the system. So it's there's every bit of this is important, Charles, but I think we just take it for granted so
Yes.
much. There's like, oh, it's just a couple of tubes and some, pieces to put the important piece, which is the cable, onto the other important piece, which is the amplifier. But it's equally important that the connector maintains the electrical properties of the conductor and, the device that it's connected to.
Yes. No, definitely. So, and which kind of leads us into, I guess, the last, portion of the design perspective before we get into, what's cool about our connector, is the center conductor grip. And really, its, main purpose is to be able to, attach to that, make contact to that center conductor without, deforming it or, causing any type of nicks, etc. If you have a loose one, or there's corrosions on it, which leads you to lead us to what you were talking about with the different materials that's necessary depending on what part of the connector that we're talking about, or any
Yeah,
tool that we're talking about. So whereas one may be, again, a better conductor, the other one may be more uh, mechanically durable. You know,
right.
especially when now I'll talk a little bit more about it over the next couple of slides when we talk about how our connector is different. But again, uh, because we're going to be eventually getting to higher frequencies, it's important that all portions of this, hardline connector not only is intact, but installed properly. So that way, like I mentioned, you can have, the best connector in the world, if it's not installed correctly or manufactured correctly, meaning that, time wasn't taken by, the company to, like we can make it cheaper if we use this material,
Right.
but that material may not hold up when there's, 90 volts that's being applied, on the cable,
Yeah.
or in cold weather, or place where they're getting a lot of rain, if you're in Seattle. So again, the type of material that's used is just as important as all the pieces kind of working together.
Yeah. Well, in where we are here in Northeast Ohio, Western Pennsylvania, fall is coming. Center conductor grip is super important, and there's multiple ways to do that, and I think we'll talk about those more
Yeah.
later. But particularly in the context of temperature changes, winter is coming. We go through this annual cycle every year, Charles.
Yes.
Where it starts to get cold overnight. the temperature variation across a 24-hour period starts to change. That has an influence on the AGCs in the amplifiers, and then at some point it's going to get cold.
Yes.
And that first cold snap of the year, like then your connectors start to suck out, right? And that's when you see those low frequency suck outs. You start to see, packet loss or outages. If it sucks out far enough, you lose voltage. So, I say all that to say this: it is really important to have good exterior, like outer conductor compression and contact to maintain the loop of the circuit, as well as good center conductor contact and compression to prevent that connector from sliding out due to the temperature changes that we talked about earlier. That cable does shrink,
Oh,
and
yes.
this was illustrated to me very early on as a very young tech. I think it was in my first year, which was 30 years ago. But we had a really cold winter. And back then we still had like 1.1 inch cable, like great big trunk cables. And it was a 330 megahertz system. And it got really cold. And that trunk cable contracted, pulled
Oh,
the
yes.
all
Yeah.
of the expansion loop out, and it actually broke the corner of an amp housing off. Like the connector didn't fail. Like the cable itself didn't suck out. It pulled so hard, it
Wow.
actually broke the corner of the amplifier housing with the seizure assembly in it off, but the connector didn't fail.
Gotcha.
So,
Which is important.
which is important.
Yes.
So,
For a lot of reasons.
yeah, we could talk about that amp housing, but the connector itself was pretty darn tight.
Yes.
So let's talk
And
about yours.
oh, yes. So the cool part of this conversation, all of it's cool, but the really cool part. So we have a new connector that we are proud of. A lot of work was put into it, not only from our end, but just feedback as we partnered with different MSOs. Engineering department or lab, their testing lab, and there's a lot of tests that was done to make sure our connector would perform. So I mentioned about submerging, the connectors in water, tensile pull strength tests, the extremity of the temperature that you mentioned, at like negative 40 degrees Celsius, but then we want to make sure that in hot weather that it would perform as well. So both end of the spectrum. Also, like testing where we would put, a certain amount of current through it, for 1 second, and then testing to see if the impedance stayed the same. So again, a lot of testing was done. So with our connector, one of the first things people notice is that it doesn't look like an aluminum connector. Our connector is a brass construction with a nickel tin plating. So when you think about brass, you hear these terms that we studied in I don't know if it was elementary school or middle school, probably middle school, when we used to discuss the periodic table. And you had to learn all the metals and their abbreviation, like gold was A or still is AU, et
AU.
cetera. And then you
Yeah.
have zinc. Well, aluminum is a metal, but brass is actually an alloy of copper and zinc. So when you think about that, you're taking these two metals and then you're putting them together, and it makes it stronger in this sense. So where aluminum is a good metal and it has a good great use, depending on what you need it for, it's a lot lighter, but it's not as durable. And where the issue can come with using aluminum is, especially when you're talking about like with those people that tend to over torque and like yourself. I wasn't going to call you out, but uh, over torque. But then also, if there's cross threading that's happening as a result of it, then you can experience something that's called galling, and that's where when you have metal that they slide together. If you think about like bearings and bushing, et cetera, is that what can happen is that they can, actually weld together. Something that's called pole welding, I think is a term. I don't know if it's still used or not, but they can weld together. So when it's time to be able to like troubleshoot, a year later or 5 years later, and you go to take off that connector, I mean, you struggle with it. And in some instances, like I mentioned earlier, is that you may have to cut it off. So now you have to, splice in another piece of cable in order to, repair something that if it was, designed a lot better or installed properly, you wouldn't have to. So with ours, what you'll notice is that the uh, the threading of it is a lot finer, and so it actually helps with preventing cross-threading, which is really cool. So as we go around and actually do demos on our connector, one of the things they first notice is that as they're putting the connector together or on a piece of cable is that, man, I could just like look away and it's almost like a magnet how it's actually the threading is going into the next component of that hardline connector. And, we had a technician, a few weeks ago as we were showing this for some installers, well, maintenance techs, and he was just spending time trying to cross thread it. And he was so fascinated by it, which was a win for us, especially when if, and I'm sure you've experienced this yourself, is if you're working in an underground area and you're trying to get that connector started sometimes, and you're like, is it cross? Because you can't really move your body around to
Right.
see if it's cross-threaded or not. So just those small tweaks and changes has made our connector a lot more durable, a lot easier to use. But more importantly, is if you ever have to go back and break it apart for any reason, whether it's troubleshooting or having to test to make sure the signal is getting where it needs to get into the housing of something, uh, it makes that easier for a technician. And hopefully, you won't see a lot of technicians cutting out our connectors because of it's been welded together or cross-threaded.
So I do want to call one thing out though. So when we're talking about the finer threads, we're talking about these here on the body of the connector, right?
Yes, yes,
Because this one is an SET standard that has to be
yes,
5/8 24 to match up to taps and amplifiers. But this
yes.
one
Great point.
is specific to your design as opposed to maybe other connector designs where they may be a little coarser and of a different material, and maybe a little harder to start. But yeah, this one is an SET standard 5/8 24 thread.
That's correct, which is a great point that you bring up just from, I guess some of the beginning conversation, which is that not only do companies as they're building new products or reinventing the mousetrap, is that we have to keep in mind that we have to play nicely to other existing equipment that's
Yeah.
already out there. Which is very important. And we don't want to make things so proprietary that it limits the market who could even use our product. So yeah, great call out about the SCTE standard, and then also when I mentioned some of the testing that we did, those testings are according to SCTE standards, so which is cool. I don't know if you've ever seen like, or I'm sure you have, but read the documents of the testing that's related to certain equipment, whether it's hardline
Uh-huh.
connectors, but it is very extensive and even to the type of tool that needs to be used in order to perform the test. So
Yeah. Yeah, I have. Obviously, I'll put my Comcast hat on for a second. We have our Downingtown lab facility, which is spectacular. And I know, Armstrong has their lab out in Colorado. I've been to that one. Um, where these labs and different labs like BEC labs in Pottstown that do a lot of this type of testing. And I know the manufacturers, you guys have your labs too, right? That have a
Yes.
ton of capability to check for dissimilar metals and inrush current and, water migration and temperature and humidity and all of this stuff. It that may be a conversation to have someday on the show, is just what all goes into testing, because I don't think everybody
Yes.
realizes how rigorous it actually is. The whole point of the test plan is to try and break it and see where it fails. And there's a really cool relationship between, companies like Comcast and you guys from, as you mentioned earlier, an engineering perspective and also a testing perspective, where, you bring us a product in revision one and, it gets tested and they say, you know, can we do a little better here? Maybe it's frequency response, maybe it's return loss, maybe it's whatever. And through that creative and engineering process, we end up with a really good product that checks all of the boxes, is tested to within an inch of its life, because it has to last for 30 years, right?
That's true.
And
That is so true.
that is the process.
Okay,
So let's
so
let's
oh,
talk
go
about
ahead.
the seizing mechanism, because
Yes.
this is an interesting one, right? And I alluded to this earlier because there's a
Yes.
bunch of different ways to do it.
Yes.
From the F81 barrels that just have, those two little spring contacts, and then other ones that are, hemispherical and, have teeth and are compression. This one's different.
Yes. So with ours, you brought up earlier about the change in temperatures, troubleshooting, an outage on a network. Sometimes you get lucky and it's a power supply, and because the entire node may be out, and you go out there and just pull a fuse or whatever. I mean, reset the breaker. Other times, you may have to change a fuse out that's blown, and then figure out, okay, what caused this fuse to blow in the first place? So was there a short, or etc. Uh, Sometimes it could be where contact isn't happening for various reasons. Whether the pin was cut too short at time of installation, so and it worked fine while they were there, and when it got colder, then it's not working. In the morning, it may work again as it warms up. So but then also this happens, on the actual semiconductor of the coax cable itself, and the hardline connector, attaching to it. So we have what's called a helical seizing mechanism. So instead of it connecting or attaching, say, at the tip of that semiconductor, it's actually in a spear formation, if you will, and it's actually making more contacts that are further down the semiconductor. So not saying that our connector will never be part of a suck out or pull out or whatever the term is today, uh, but it will help to eliminate that because of the way it's designed. So if you think about it visually, for those visual learners, if you had like two pieces of plywood that are attached with a nail, eventually you could work it out. But if they were attached with a screw, it's a lot more work to be able to pull those two pieces of board apart. But because of that helical design, you can actually, and we've done this in front of technicians, many technicians over the last probably 6 or 7 months, as we are showing this connector, is that even with hand tightening our connector, and when they take it off, they can see how further down that season mechanism is attaching to that semiconductor. So instead of it being on the edge, where some of the connectors that are out in the field may be, and as you and I both know, the moment that suck out occurs is not at 1 p.m. in the afternoon when there's a lot of technicians working and it's a
Right.
beautiful sunny day. It's always when, there's an on-call person and it's,
Yeah.
4 o'clock in the morning and
It's
it's
cold, it's
cold,
raining,
backyard easement.
snowing.
Yes.
Yeah.
And my luck is because you would rule it down to, is it the connector on the output of this device, or is it the input of the other
To the
one?
next one.
And,
Yeah.
sometimes it's the luck of the draw. So, again, just just that design perspective of it having that helical season mechanism uh, is worth its weight in gold, or in this case, brass, as it relates to our connector. No pun intended.
Yeah. I also wanted to touch on, the 3 gigahertz spec. We, I think we were both looking for the frequency response plot
Oh,
of
yes.
the connector, and we couldn't find it. But I know it was done, and this is one where I don't think it's important to the technicians, but I do think it's important for them to know that it will work all the way out to 3 gigahertz. So
Yes.
that's the future resistive part of it. And then the last bit, the return loss, when we start talking about the higher frequency, higher power DOCSIS technologies, DOCSIS 3.1, DOCSIS 4, like return loss gets really important. And so that's a measurement that it gets tested against, to minimize reflections and the possibility that the connector itself is contributing to a reflective cavity. So
Yes. And to
it's a
add to
big deal.
that last one with the return loss is that there's a return loss value for kind of like how you were talking earlier about every component of the network. So as it goes through a set-top box, amplifiers, hardline
Splitters.
connectors, there's a level for each one of those. And come to your point from an SCTE perspective, we want to make sure that we are exceeding if possible those standards or expectation, but at a bare minimum that we are meeting those expectations. So yeah, you're right. It doesn't get talked a lot because by the time a technician may focus on that part, they have already had to deal with other stuff, like signal gone and,
Yeah.
or leakage. And now they have, the FCC on their back. So as they repair those things, hopefully it fixes, the return loss stuff, uh, provided that they were designed correctly in the first place, the connectors and et cetera.
And I think sometimes, Charles, those are the issues where if a technician has a customer experience problem, right? But they don't necessarily understand what it is. And we just start changing parts. We start changing taps, we start changing, connectors, we start temping spans of cable until the problem goes away, right? If you
Yes.
can't define what the actual problem is. And I think that's the tricky world of the gremlins that maybe, when we start to get into these more advanced technologies, some of the legacy components that were installed 20, 30 years ago were just never designed to operate in that
Yeah.
environment with that much total composite power at that expanded bandwidth in, with the return loss specs and the frequency response performance that we expect out of today's components. And technicians probably don't either. They just know at some point, like I've replaced enough stuff with obviously new stuff that the problem goes away.
Yes.
And, so in as much as possible, I want to get technicians thinking about, well, why did it fail? Like, what did I replace? And why did it make the problem go away? Like, what was wrong with it in the first place? And part of the problem, or I guess what the statement would be, is there was nothing wrong with it at the time that it was installed because it was designed and manufactured with a certain set of limitations that they were testing to. And I
Yes.
and I can attest to this. When I came to Comcast Corporate 10 years ago, I became very close with the folks in the Downingtown lab and got familiar with their test procedures and their test plans and the things that we were testing for. I've seen it evolve significantly over the last 10 years. I'm still very close to the Downingtown lab.
Okay.
and their test plans and procedures and the things that they consider as they're testing new products and components are very different than they were 10 years ago, 15 years ago, 20 years ago, because of the changes of technology and the things that influence, the transmission of electrons through conductors, which is effectively what we do,
Yes.
right? That's what it's all about. And it's as simple as that, honestly. It's we transmit photons through optical conductors and electrons through metallic conductors. That's what we do, because that's how we deliver services. In every component, including these connectors, influences how those electrons flow through those conductors, just in ways that we don't even think about.
Oh yes, yeah, and just briefly, when you were talking about future proofing, you know, as someone on, say, the manufacturing vendor side of the house is that, we always, well, we should want to make sure that we're putting out products not just for today, but for future expansion. And when I think about, like, for people that are into sports, and I know it's like football season now, is that when you think about the difference between a quarterback, yes, a quarterback and a great quarterback, especially when it comes to like running routes. Uh, a quarterback will throw the ball to where the receiver is. A great quarterback will throw the ball to where the receiver
Receiver's
is
gonna
headed.
be, yeah.
So that way they don't lose momentum. And the same thing should be as you develop product is that, yeah, it'll work if you have a 1.2 system, but as soon as you go to 1.8, then what, you have to buy another hardline connector or another tab plate or
Yeah.
whatever it is. So again, it should always be about how do I scale my product, without uh, creating just a niche for, just a handful of, companies or people or whatever. So,
Now, yeah, that's actually a great analogy, because when you think about a quarterback and a receiver, you could go with, Joe Montana and Jerry Rice, or
yes.
um, pick one, Peyton Manning and Marvin Harrison, or, pick your quarterback receiver. They were on the same page. And in the same way, the manufacturers and the operators also have to be on the same page. And, I'm repping the Cable Labs today, and SCT,
Oh,
obviously, as,
yes.
as well as my Amphenol hat. Because we all have to be on the same page about where we're going. And that's where the development of the standards with SCT and Cable Labs and the vendor community and the operators, so that we all know where we're going, so that when we throw the
Yes.
ball, there's some faith that the receiver's going to be there to catch it.
Oh, yes.
All right, it is football season. We could spend a lot of time there, but
Oh, yeah. Go
I
Indy and Denver. So I'm, when
well,
in
I'm a
Rome, do
Browns
as the
fan.
Romans.
Yeah. So, all right, enough of that. But so craftsmanship again, is does it matter? The answer is yes, it absolutely
Yes.
does. And man, when we start talking about tools, I want to spend some time on coring tools, because this
Okay.
this one, I get fired up about this one. And we see this more and more now. Again, not to beat up the new technology too much, but the newer DOCSIS specifications are more. I don't want to say they're more craft sensitive. There's always been craft sensitivity in our
Yes.
industry. There always has. But I think it's as important, if not more important than ever, to really focus on the craftsmanship, because, there's millions and millions of different components that have to be put together and properly installed in order to work, to move these next generation technologies, through the network without problems.
Yeah.
And this is one we just can't talk about enough, is craftsmanship is so important.
Definitely. And out of all of the slides, outside of our cool new connector slides, which, I think is really cool. This slide is very important, especially that first statement, where we talk about craftsmanship. Most hardline connector craftsmanship issues are time bombs, meaning that you won't see them at time of install. If, sometimes if they're installed incorrectly, or, over torque, or, cross-threaded, etc., they will show up weeks, months, years later, or when, you go through a lot of rain, or whatever the environmental issues are. So, if you think about like the O-ring, if it is nicked because of, improper coring, a tool is not new or hasn't been tested in a long time, that O-ring being nicked, for a couple of weeks may not be an issue. But over time, as moisture gets into it, and then you start to run into issues with certain frequencies because of when water gets in the cable, which end of the spectrum does it tend to affect first. So again, because they don't happen sometime at time of installation, that's what makes it more difficult to troubleshoot, but then also why it's more important, to your point, that we are, very considerate when it comes to, and meticulous when it comes to craftsmanship. Outside of just being proud that, you do quality work, you
Yeah.
know, that should probably be your first reason why you want to do something correctly. And then even not even on the customer side of the house, with trouble calls. The only time that we should ever visit a customer is time of install, or if they're upgrading. We
Yeah.
shouldn't have to go out there because they're having issues. And I know in the real world things happen. Sometimes it's customer education, but if there's a problem on our end, and especially if it's things that we can control, we
Yeah.
definitely want to make sure we do those things correctly as it comes to craftsmanship.
Yeah, there's so many things that are outside of our control, right? Whether it's squirrels or whether it's, catastrophic damage, car hits pole, trees fall down, storms, all that kind of stuff. There's a entire universe of things that are outside of our control. And we're always going to need to fix those, but it's the ones that are within our control. And I think about silly stuff, just like broken lashing wire or, improper expansion loops and hardline cable, or not having straps and spacers in the right place, or, just pole attachments, things like that, that it eventually will affect the cable, because we talk about, the temperature cycles and heating and expansion and humidity and wind whip and, the the load, the stress of snow and ice and all those things, not to mention, corrosion and oxidation and the effects of, humidity and moisture migration and intrusion and all that stuff. Um, the simplest things, just, keeping the pole clean, making sure that your straps and spacers right, that your lashing wire is not busted. That's before we even talk about coring tools and the
Yes.
actual installation of the connector itself. And this didn't render super great. That's probably my computer, but coring tools, I, I think we forget that these are highly precise tools. Like the tolerances and the performance of these tools, these are highly precise tools that have to be cared for in order to properly shape the cable and to get the right length on the center conductor and not
Yes.
damage any of the materials. We throw them in the splicing box and they get banged around in the bucket and, all that stuff. But man, if you're splicing cable, you need to take care of your coring tools.
Yes,
And
I mean it's no different than when it comes to safety equipment. You want to make sure that this is the equipment that's going to keep you protected. In some cases, keep you alive. So, which is why when you think about some of the standards as it relates to safety, like the ANSI standards, with hey, if you're going to use safety glasses, they need to be a certain rating. Same thing with hard hats, and a lot of companies have policy that says hey, you shouldn't put stickers on your hard hat. And the reason it being that there could be cracks in it that may be hidden as a result of all these extra stickers. So to keep that from happening, the only stickers that should be on there is the one that says the company logo. Same thing with your safety belt. There's a reason why your safety department says, hey, you should check the safety equipment daily when for certain ones like your ladders and your safety belt, weekly or monthly as it relates to your vehicle to keep you safe. Same thing with tools, like you mentioned, is that if you're using a tool that you hadn't checked or replaced components of it in a long time, it can cause problems. And, to not go through each tool listed here, but one of them is, I want to say it's pronounced chamfer portion of the coring tool,
Hmm.
is that if that stuff starts to wear out, you can cause problems and score the outer part of that cable and create leakage, that can cause problems later. But I heard a story once where someone's coring tool was so used that, and I want to say that that part was missing, that they were actually using a 500 coring tool on a 625 piece of cable and didn't even recognize it until after the fact. So, kind of like you mentioned, is that it's very important that all of your tools are working properly, and that you're inspecting for like burrs on the conductor end and making sure the dielectric is clean, and like I said, the outer conductor hasn't been damaged.
Yeah. Yeah, because metal fatigue is real, right? The cable and the connector are, potentially made out of different materials, and they are gonna heat and cool and expand and contract independently of each other
Yes.
slightly. We're in some harsh climates that get really super hot and have, large diurnal temperature swings. That's a real problem if they're not installed properly. So all of these components are critically important, getting the right center conductor length and getting the right shape of the center conductor to feed that into the cable without damaging. But obviously the coring tools, there's a bunch of different styles of coring tools out there. They're all good, but it is, critically important to maintain those tools. So we've only got a few minutes left,
Okay.
Charles. So we got to start to land the plane.
Okay.
Um, so let's talk about, to wrap things up today. You know, how do you put it all together? The design of the connector itself and the craftsmanship and the tooling to make sure that we're giving ourselves the best possible chance to succeed as we're, installing these super cool new hardline connectors.
Well, I guess the training answer in me is through training. And part of that is that when you have especially in our industry, if technicians are like myself, very hands-on, we want to get to the cool stuff. Like, hey, yeah, we're taking this connector, putting on to coax cable and plugging it to a line extender or amplifier. Man, this line extender amplifier has all these little cool parts of it. I want to learn that. And so they want, chase the cool stuff. So proper training is very important, and training from the perspective of a partnership between the company and their technicians, as well as the vendors who's creating these products. They know how it was designed and, what may be a little different versus some of the other pieces of equipment that they're using currently. So proper training, QC. A lot of technicians they don't like to know that people are going behind them and checking their work. But it's important. So that way, standardization is very important of how we, whether it's, you mentioned lashing wire, how it's installed, or, distance between cable from telephone. There's a reason why there's standards around it, and we need quality control as relates to installing hardline connectors. So that's another way of taking the design perspective along with the craftsmanship. And I always say trust but verify, and which is a third part. It's not that you assume that they're going to be doing something wrong, but they may not know that they're doing something wrong. And instead of just saying that they're doing it wrong, tell them why it's wrong. And I think some of the things that we've discussed today about the importance of understanding how a connector is designed and why that part is there, and then also the craftsmanship, I think we can provide technicians with why they should do something a certain way or not do something a certain way, instead of just saying because I told you so. So I don't know if that answers your question, but again, training, mentorship, quality control is very important when it comes to not only hardline connectors, but anything that we put in the network.
Yeah, as the engineer in me says, as much as I love training, and I do love training, I also want to understand the engineering and the design of it, because function follows form. So
Yes.
if I understand how a thing is made and why it's made the way it's made, then it's I have a fighting chance of getting it right. And any of us that want to be good at what we do and take care of our customers and be craftsmen in this space, QC shouldn't be a bad thing. If I'm doing it wrong, I want to know why, or I want to
Yes.
know that I am doing it wrong, and then figure out why I'm doing it wrong so that I can fix it. Because you know it, we do need to go fast, because the all the networks are undergoing rapid expansion. So going fast is good, but you do have to also take the time and do it right the first time. Because if you don't have the time to do it right the first time, you will find the time to do it the second time.
Yes. At 2 o'clock in the
That's
morning.
yeah, that is a fact. So, Charles, thank you very much for taking the time and introducing us to your connector. I think there's more to talk about here. We've got some more material. So, why don't we get together again and pick up where we left off on the next one?
I look forward to it. Thanks for the invite, Mike.
All right. Okay, folks, thanks for joining us about the hardline connector training today. So stay tuned. We'll have part 2 of this for you coming up soon.